Hello and welcome back. So we have understood, a sigmoid function or logistic regression algorithm learns these weights when you pass your training data. So there are, some more conventions in logistic regression. The logistic regression sigmoid function is also denoted as g of z. What is z? The linear combination of input values. And the sigmoid function is always, many times is referred as 1 by 1 plus e power minus z also, or z. Z is equal to the linear combination of input values. As we have seen, the logistic regression algorithm always outputs a number between 0 and 1, and it is never equal to 0 and 1. 0 less than h of x less than 1. So we will see why it is in the next slide. If you look at this curve for different values of z or linear combination, when you substitute into 1 by 1 plus e power minus z, g of z, we have got this curve. It's a non-linear curve. On x-axis we have taken the linear combination of inputs, and on y-axis we have taken the logistic regression of output. 0.5 is the threshold where the positive records are going to get probability which is greater than or equal to 0.5, and the negative records, the records belonging to 0, we are called as negative records, will get a probability less than 0.5. Why it is and how it is? Let us try to see. Suppose that your z value is less than 0. What is z value? Linear combination of inputs. Theta 0 plus theta on x1 plus and so on theta and xn. The linear combination of your inputs is less than 0. When you try to substitute that value, suppose that you take it as minus 10. When you try to substitute that linear combination value into your logistic regression function, it is 1 by 1 plus e power minus of minus 10. It's going to be plus 10. 1 by 1 plus e power 10 is going to be less than 0.5 because 1 by e is equal to 2.37 some number, right? To the power of 10 is going to be a big number. 1 by a big number is always less than 0.5. And if you take the z value as greater than or equal to 0, a positive number like 99, you try to substitute it, it's going to be e power 99 by e power 99 plus 1. It is definitely going to be greater than 0.5. 1 by 2 e power 0 divided by e power 0 plus 1 is equal to 0.5. And if you take 2 by 2 plus whatever, right, it's going to be definitely greater than 0.5. Now this is definitely going to be greater than 0.5. If you look at the graph, right, it will never touch the 0 and it will never touch the 1 because e power 1000 divided by e power 1000 plus 1 is greater than 0.5 but not equal to 1 because e power 1000 divided by e power 1000 plus 1 is a minute small number greater than e power 1000, right? So it is, if it is e power 1000 by e power 1000, it's going to be 1. We are having a little bit of number there, so it will never be equal to 1. The same way on the other side also, if it is 1 by 1 plus e power 1000, it is not going to be 0, right? Maybe your interpreter like Python or maybe the compiler like C language may not be able to calculate the number and show it, so it may actually round it off to 0, but it is not 0. So logistic regression function always gives you a number between 0 and 1 and it will never be equal to 0 and 1. That is one point. And the second point is, when your linear combination, the linear equations outcome is less than 0, the record belongs to negative class, 0 class. When the z value is greater than or equal to 0, the record belongs to positive class. This is called as perceptron. When your linear combination is less than 0, the record belongs to negative class, 0. If your linear combination is greater than or equal to 0, the record belongs to positive class, 1. So the same thing is simulated using this formula, 1 by 1 plus e power minus z. You can use linear equation to make classification by taking 0 as the threshold. Or you can take the logistic regression equation and say 0.5 as the threshold, because logistic equation gives you a number between 0 and 1. Linear equation gives you a number between minus infinity and plus infinity. Either way you can do classification, but logistic regression is more convenient because it gives you a number which is like probability. So that's about how exactly the logistic regression function is giving you a number between 0 and 1. And linear equation can also be used to classify a record when you take 0 as the threshold. Thank you.